Hello everyone, in our last video we learned about what an interface is and how to implement one. Today we are going to answer a deeper question. Why do we actually need interfaces? Before we talk about interfaces, let's quickly understand something important about methods. In Java you can pass an object as a parameter to a method, just like passing an int or a string. And here is something really powerful. If you declare the parameter as a parent type or interface type, you can pass any object that is a subclass or implementation of that type. Let's see why this matters with a real example. Imagine you're building a computer store application. You have different types of computers, like desktop and laptops, and you have a method that needs to work with any type of computer. If you write the method to accept a specific type like desktop, and write something like this: public void start computer desktop the int curly braces the dot start, just an example. So this method only works with desktop. It cannot accept a laptop, right? But if you use an interface as the parameter type, the method becomes more flexible. Let's see how. Let's create a computer interface first. Name it computer. Now we declare two methods here. Void start, void shutdown. Now let's implement it with two different classes. The first class we name it as desktop. This class implements the interface computer, As you can see, we have an error here because we have two classes in computer interface and they should be implemented in the desktop class. So public void start, the first method was start, a second one was shutdown. Let me just copy the name. This method. And with our own implementation, for example, I write desktop starting app. Now let's go for the second method. Copy its name to avoid any mistakes. Paste it here, curly braces, and with our own implementation. For example, desktop shutting down. Right? Now let's create another class. Name it laptop. This class also implements the computer interface. The same error occurs here. Copy the name of the method, implement it with our own way. Void name of the method. And here I want to write laptop starting app. Now let's go for the second method, which is shutdown. Copy the name of the method, paste it here. Now I write my own implementation. For example, laptop shutting down. Right? Now let's write a method that accepts a computer interface as its parameter. It's interesting, right? A method that accepts a computer interface as its parameter. So let me create another class. Name it computer store. In here I create a method, public void start computer, and then I pass the computer as a parameter, C, the name of the variable, and now I write C dot start, the first method that we had here. Now look at how flexible this is. Let me create the object. Object of this class is copy the name of the class, create a reference variable, equal new, the name of the class, parentheses and semicolon. Now we can call, before that we create the object of desktop, equal new desktop, semicolon, laptop, object of laptop, right, with lowercase letters, laptop equal new laptop, semicolon. Now let's call each method. I copy the reference variable dot operator start computer. I call this method. Now I pass any of these reference variables. For example, desktop. Now let me go for the next one. Store dot start. And now I go for the laptop. As you can see, we have the output desktop starting up, laptop starting up. We can do the same for the second method. So here we have one method, which is start computer, two completely different objects, which are desktop and laptop. Both work perfectly, right? And here is the best part. If tomorrow someone creates a new class called server that implements computer, the start computer method will work with servers too. So, without changing a single line of the method. This is loose coupling. The computer store does not depend on any specific computer type. It only depends on the computer interface. Any class that implements computer can be used. So, now let's summarize the three key reasons why interfaces are so important. Reason one is abstraction. As you know, interfaces achieve 100% abstraction. They completely hide all implementation details, showing only what must be done. And reason two is multiple inheritance. A class can only extend one class in Java, but a class can implement an unlimited number of interfaces. And reason three, loose coupling. When your code depends on an interface, not on a specific class, it becomes extremely easy to change, extend, and maintain. So that is the need of interfaces in Java. If you enjoy watching this video, make sure to like and subscribe the channel so you never miss a video. See you in the next one.